A very good afternoon, everyone. I believe everyone can hear my voice.
Good afternoon, sir. Good afternoon.
A very warm welcome for session 4 on data science and machine learning. If my voice is audible to everyone, please confirm me on chat. Please quickly text on chat if my voice is audible to all the participants, those who have connected with us on YouTube. So guys, as you all are already aware that we have been working on telecom data set as well as a house price prediction data set where a house price prediction data set as well as a telecom data set where our objective is to extract knowledge from the data available. And we are doing this with two ways. We have a user interface with Dataiku where we are applying this data science flow, machine learning flow, as well as we are coding in Python as well. One thing which I would like to inform before I begin today's session, you all have to be very focused with what all sessions we have covered till now, because tomorrow we will be having a quiz. It will be a preliminary evaluation test. All the participants has to attempt that preliminary evaluation test. It will be conducted in the session tomorrow from 2 p.m. onwards. So all the participants, those who would like to have the certificates from Hackveda as well as from RGPV, they have to be present available tomorrow at 2 p.m. They have to attempt the test live. We are going to give the link of the test tomorrow. Those participants who will score at least 50% in tomorrow's test will only be able to be eligible for the certification for from Hackveda as well as from Rajiv Gandhi Pradyogiki University. As well as there will be another test which will be the final test. This test we are going to conduct on 15th of June, and the students, again, those who will be able to secure above 50% marks, will get the final certifications. So tomorrow and on 15th there will be two test programs will be conducted, and you all have to be a part of it. You have to attempt the test. Once you will be able to successfully clear the test, then you will be able to get the certifications and whatever is the process. Okay, now so let's go for it. In today's session we will be discussing about data transformation, mining and evaluations, and how we can extract knowledge from the data set available. Once we have extracted the knowledge, we can identify the best possible machine learning algorithm or the mathematical equation. That equation will be integrated with a web application or with a mobile application, so that finally you can make a product, and that product can be used by consumers. As from the very start, I have always been telling you that consumers buy solutions, they don't buy technology. So machine learning is nothing if you are not making a product out of it, if you are not making an application out of it, and you are making that application reach to the consumers. Once your consumers are using that application, they are getting the solutions to the problem, only then your machine learning activities will be considered as effective, and you can call yourself as a data scientist. Moreover, one thing more which I would like to quickly remind you all, we have been working on this telecom data set for a position which is data analyst position at Reliance Communication. Reliance Communication is hiring data scientists and data analysts who can actually evaluate mobile users demographics and various other information. So in that motivation, we are conducting this session so that everybody will get to understand about how data analysts work at Reliance, what kind of data is available to them, how do they extract knowledge out of the data, and using the mobile users demographics and important information, how they can perform ad targeting, marketing, and how they can improve the sales procedures, as well as how they can improve the services which are offered to the consumers. So all these things we will be doing it in our session. So again, a very good afternoon to all the participants, those who have joined, and let's get started with the session. I'm sharing my screen with all of you. Now here, so let us just quickly start with our softwares which we are using. One, we are using Google Collaboratory. Google Collaboratory, as you all know, offers you an open source Python Jupyter notebook where you can write your Python code and you can quickly access that from collab.research.google.com. We have started working on a script and I have already shared the link to the script with all the participants. Again, all the participants, those who have joined today, I'm sharing my house project script with all of you, which we will be coding and which we are coding from last 2 to 3 days, so that you all will come on the same page. You all will be aligned with me and you can continue today's demonstration from the code here. Okay. So guys, I'm sharing the link with all of you. Okay. Now let's see. So let's log into our Dataiku account as well as let's log into house project. So just to give you a quick brief of what all we have done till now, we have started working on this project, Data Science Devanshu Shukla House Price Project initially. This is the first project which I have taken to explain you what are variables, what are response variables and dependent variables and independent variables, how we make use of these variables in order to identify the correlations. We have done that yesterday. Once you can calculate the correlation, it means you will get to know how you can actually predict the response variable using the independent variables. And you can also get to know how many independent variables are positively and negatively influencing the response variable. So our objective is to always identify the independent variables, those who are highly positively influencing or else negatively influencing. Using these positive and negative influencing variables, we can actually calculate the output variable or else the response variable. So once we have got the output variable calculated, we can match it with the output variable available in the data set. If they are close enough to each other, that means the equation which we are using to calculate is authentic and it's correct. It is more accurate. And then we can use that equation to integrate with a web application or a mobile application so that it becomes a solution for a specific type of problem. And users can actually use that mobile application. And behind the scenes, data science, machine learning can actually help the user solve the problem. Okay. So let's quickly understand the flow of the project, which we have implemented till now. So yesterday, what we have done, we have started working on house dataset. We have started pre-processing. The pre-processing stage has been implemented where we worked on removing the null values from the dataset as well as converting the text data into numbers so that they become machine learning ready and analysis ready. Now we will continue with the next stage. Okay. So when it comes to the stages, and just before I reach to the stage, I would like to quickly remind you with one diagram which we have been referring from the very start, which is the knowledge discovery process benchmark in order to implement machine learning. Second one is cross-industrial standard process for data mining. And third one is sample, explore, modify, model, assess. These are the three benchmarks which we actually use in order to implement machine learning. And to give you a quick reminder of what these benchmarks are and how and at which stage we are currently available and how we are going to use it. So I'm going to give you a quick description about it and then we will resume the session. So I have created an interns group 7 for all of you. And under this interns group 7, under this card, RGPV Machine Learning Workshop, 8th June to 15th June, we have a Python document available over here. I have already shared the link of this Trello card with all the participants. Again, I'm sharing that with you for the people, those who are new. Okay, so here I have shared the Trello card link as well as I'm sharing the link of the Python document also once again. And we will be using this document in order to quickly refer to the benchmark frameworks which we can use to implement machine learning step by step. And there are 3 standard benchmarks, as you already know. And these 3 standard benchmarks are as follows. So I'm going to open that for you. This is the PDF file. Under this PDF file on page number 2, just to remind you all, this is our knowledge discovery process in which we have the data, we can perform selection, we have done the pre-processing part, which we have done yesterday. Our today's objective is to implement the transformation part, okay? As well as we will be implementing data mining and interpretation and evaluation. All these 3 stages we will implement to extract the knowledge out of the data. This will be our objective for today. In transformation, what we will be doing, generally the definition says independent variables are of different scale, okay? To compare and extract insights, we have to convert them into a common scale, okay? And the common scale is between 0 to 1. So this actually means, why would you be transforming the data? Data transformation will be required because suppose we have price available in the data set, we have bedrooms, bathrooms, lot size, all this information is available in the data set. As you can see, the price value ranges from a minimum value to a maximum value, and that value is in thousands. Lot size also varies in thousands, but it is quite in a small range with respect to the price, which means it falls under 1,000 to 5,000 square meters. Similarly, when you reach out to bedrooms and bathrooms, they are also numbers, but they range on a very common scale, on a very low scale actually, and the value ranges from 1 to 6. So now you can see that in case if you want to represent all these 3 values on a common graph, you won't be able to perform the comparison because the price will display in a very high magnitude on that graph, and these lower values like bedrooms and bathrooms cannot be even displayed. I'm going to show you what I'm trying to explain. So in order to represent all of them and in order to have appropriate comparison between them, we actually transform the values on a common scale. From different scale, we are going to convert all these values into 0 and 1. And there are 2 techniques which we generally use here. The technique is known as standardization of the data, and second we call it as normalization of the data, okay? Generally, standardization also falls under normalization techniques only, and there are 2 techniques generally which is used. One is standardization and second one is min-max scaling, okay? So that we will be implementing today. So I'm going to tell you how mathematically they are implemented, followed by how you can make use of mathematical functions in order to implement them on data and perform normalization so that your data is analysis ready. So that's what we will be doing, and our objective will be to implement transformation. Post that, we will do mining, interpretation, evaluation, and we will extract the knowledge. Now, just to quickly give you a look, what do I mean with the process of transformation? Here, under your Python code, as you can see, this is your data set available. In this data set, you can see that your price is of range in 10,000s, okay? Lot size is in range of thousands, and other variables like bedrooms, bathrooms are in range of 1 to 5, 1 to 6, and driveway, recreational room, and etc. All these values are on a very small range, only 0 and 1. So now what we have to do, we have to convert all these values into a common scale, and that common scale will be between 0 to 1. Okay, so this means you have to perform some mathematical computations in such a way that this price, lot size, bedrooms, bathrooms, and all your driveway, recreational room, etc., they all will be represented on a common scale between 0 to 1. This is what we have to implement. And this technique is actually known as normalization. Okay, we generally call it as transformation, transforming the data from large scale to a common scale. And transformation has a technique which is known as normalization. And normalization actually has two techniques. One is standardization. Generally, it has many techniques, but the most common used techniques are standardization of the data, as well as the second technique is known as min-max scaling of the data. Okay, I'll write it here. Let's say min-max scaling here. So these are the techniques which you will be implementing. So now let me take you further that how you will be implementing these techniques. So in the previous session, I have already told you how you are going to convert these text values into numbers, and then you will be able to calculate the correlations. Okay. So here, if I quickly show you the data now, if I quickly run the data here, let's just quickly connect it. We have to run all the previous cells which we have executed yesterday, and then I'm going to show you the data of different range, their minimum and maximum values, and then we are going to transform the values. Okay, so transformation is a very important process because once the data is transformed, you can actually compare it easily. Okay, and you can actually be able to identify the relationship among the values, and you can plot them on a graph so that you can visually compare it as well. Now, so how we are going to do it? In the first step, we have read the data from housingmodified.csv file, and we have saved it into a data frame. Data frame is a two-dimensional size mutable data structure, which we generally use in Python. And I'm going to write it here. Data is a data frame here. Data variable is a data frame here. Okay. And what is a data frame? Data frame is a two-dimensional size mutable data structure. Okay. So what it does, it represents data of two dimensions. And what exactly are two dimensions? The one dimension is rows and the second dimension is columns. So whenever you have to represent a two-dimensional data in Python, you can actually use a data frame. And data here is of data frame type. Okay, this variable data is of data frame type. So you all need to know about it, because in the test tomorrow, you will be having questions like this. What is a data frame? And out of the output, just check which variable is a data frame. So you have to select the multiple choice questions. So the test which we are going to conduct tomorrow will be a multiple choice questions based test, but it is a guarantee that you will be able to solve it only if you have watched all these videos in sequence, because the questions will be customized from our sessions only. So if somebody has not watched it, it will be very difficult for him to answer. So inform all your friends also, those who might be watching the sessions after this live class. So ask them that they have to observe all these video sessions, these 4-day sessions, whatever we have conducted. Again, they should practically implement it. And once they have implemented it practically, only then they will be able to sort the problem out. Okay. So now coming back to our code. So we have got a two-dimensional data frame read. Now what we are going to do, I'm just explaining what we have done yesterday. We have calculated the correlation. And once you have calculated the correlation, you can see since the variables were in text, many of the variables were in text format. So we have not got the correlation of all the columns. We have only got the correlation of the columns which are mathematical or integer in nature. Okay. Now, what we have done, we have actually converted all the binary categories into 0 and 1 using label minorizer. Then we have converted n categorical data into numbers using label encoder techniques. Once both of these has been done and we have again calculated the correlations, then we have got the correlation of all the columns available in the data set, since the data has converted into numbers. So above you have seen that their data contain both type of variables, integers as well as the text. But after encoding, after performing pre-processing, if we quickly check, we have the data in the integer and in the numerical format only. So now you can see that we have the price, lot size, bedrooms, bathroom, stories, driveway. All these values are available in numbers only. But now the problem is that they are of different range. Okay, so if you want to see the range, I'm going to quickly show you the range in the next line of code. So let me just quickly print the top 3 lines of code just for reference. And in the next line of code, I'm going to show you the range of all these. Okay, so here, let's just quickly check. Show the range of values available for each column in dataset. Okay, so let me just quickly show you a range. Let's say, in case if you want to quickly see the minimum value of price in the data. Okay, so what you can do is you can actually quickly call the val minimum, and you can store into minimum price. Similarly, you can quickly collect your data variable. From the data variable, we can call the price column, and we can get its max value, and we can save it into maximum value of price. Okay, and now let's say I'm going to print it. Let's say like this: price minimum value of price is %d, and maximum value of price is %d mod. Okay, so we are going to have a tuple with minimum price comma maximum price. Okay, we can quickly print it somewhat like this: minimum price comma maximum price, or else you can print it one by one also, as well as you can print it in this way, where you can define the value which you want to represent. So if you want to print a string, you can use %s. If you want to push a value of an integer, you can use %d. Okay, and max value of price is %d. So this is the mod sign. What is going to happen? The value of minimum price, the value of first tuple will be stored into %d, and the value of second tuple, the value at second index of the tuple will be stored at the representation of %d at the second position. So similarly, you can see that the minimum value of a price in the data set is 25,000, and the maximum value of the price in the data set is $1,90,000. Okay, so this is a range. So now you can see that the range of the prices, it starts from 25,000 USD and it goes up to 1,90,000 USD. Similarly, if you want to check the range of other, sorry, let's just quickly, I need to execute it again. Somehow I got that deleted. Okay, just a moment. We'll just quickly rewrite it. Okay, so I'm going to write minimum price as data of price dot max dot minimum. Then we are going to get the max price. Let's say data of price dot max. And finally, we are going to have a print statement: minimum value of price is %d and max value of price is %d. And then we are going to use mod again with a pass a tuple minimum price comma maximum price. Okay, so once we run that, we are going to get the values of price. Now again, I'm going to use second column, and let's say this will be a lot size column. So show the range of lot size. Lot size is the second type of value which we have, which has range of big values, but only up to 4 digits. So we are going to calculate it somewhat like this. Let's say minimum lot size will be data of lot size dot minimum. Okay, and you can get the maximum value of the lot size. You can actually call it in this way also. You can call the data frame, and from the data frame you can get the value in this similar fashion. So either you can call it with the index page based approach, as well as you can also call it as a object based approach. Both of the ways we can access the columns from the data frame. And similarly, we are going to quickly print max value of lot size, minimum value of lot size is percent D, and max value of lot size is percent D. Okay, and we are going to quickly have the minimum lot size and the maximum lot size. Okay, let's print that. Okay, that is minimum lot size like this. Okay, I have used percent here. Now here, so you can see that the minimum size is, and for major understanding, you can use it somewhat like this. This is in rupees. Sorry, this was US dollar. US dollar, and these values are in square meter. So let's say I'm going to call it as square meter, and this is percent D square meter. Okay, so we are going to get something like this, that the lot size minimum value is 1650 square meter, and maximum value of the lot size is 16,200 square meter. So you can see that now there is a difference of range. Price was up to 1,90,000. Lot size is only up to 16,200. So when we are going to plot both of the values in a graph, okay, suppose I make a graph here, just a random temporary graph I'm just making here, just to explain you and to give you a quick concept, just to give you a quick understanding. Suppose we have a graph somewhat like this, in which we want to make a plot for price. Okay, so let's say if we say that the price is 16,000, so from 0 the price could range up to 16,000 or something like this. Sorry, 1,90,000 was the top price. 1,90,000 was the top price value. Similarly, when we will be representing lot size on the same graph, we can only go up to thousands. Okay, and let's say this value will be somewhere around 16,200. This could be the max value. But all the other values which you will see now, the other values, like if you will see the value of, let's say, bedrooms, bathrooms, stories, driveway, so they will be very minimum. They will be on a range of 0 to 1. So they will be somewhere here only, okay, at the very bottom. So it will be very difficult to compare all the three. It will always be very difficult to compare the price with respect to the lot size and other values. And you might say, why do we need to compare? We need to compare because if we have to calculate the price, we have to identify what all dependent variables, what all independent variables are positively or negatively influencing the price. Okay, so if we can get to know the facts or the variables which are actually influencing the price, then we can actually calculate the price of a object. Okay, and why we are trying to calculate? We are trying to calculate so that we get to know the right equation which can help us calculate the price of new houses in future. If we have got their independent variable properties available with us, we can calculate its price and we can estimate the price. So for that, okay, so I'm going to make a graph as well to show you why they are in different range and how you can convert them into a same range so that they all can be compared properly. Okay, so third, one more I would like to show you. Let's say, let's take a very small range also. Show the range of, let's say, bedrooms. Okay, so minimum bedrooms will be data of bedrooms. You can quickly call it as data.bedrooms.minimum. Similarly, you can get the max bedrooms, data.bedrooms.max, and let's print the values out. Max value of bedrooms is percent D, and sorry, minimum value. First, we are going to print the minimum, and the max value is percent D. Okay, we use the mod minimum value of bedrooms, comma, maximum value of bedrooms. So we are going to run this. Now, once we run this, you can see that now this range is very small. This is between 1 to 6 only. So it will become very difficult to compare the price with respect to bedrooms, and we won't be able to get that in case if the number of bedrooms in a house is increasing, is there is any effect on the price of that house or not. Okay, so that is what we need to quickly identify. And in order to make the data converted in such a format so that it becomes comparable, we have to make use of data transformation techniques. Okay, I hope this is clear to all the participants. Those of you who are watching, just confirm me on chat on YouTube if till now it is clear to everyone. Okay. Okay, so just confirm me on chat on YouTube if there is any question till now, or if you all are able to implement it perfectly, just confirm me that you all are able to execute the scripts step by step as I am executing on my machine. Great. Now let's proceed to the next part of the code. So we have got the minimum values and the maximum values. Let's just do one thing. Okay, let's just make a quick plot out of it. Okay, so how we are going to make a quick plot? We can use matplot library. So now what we are going to do, draw a graph of all the values in the current data frame. Okay, draw a graph of all the values in the current data frame. So what we are going to do, generally to draw the graph, we make use of a library known as matplotlib.pyplot as PLT. So what is matplot library? It's a library which can actually let you plot the graphs like line plots, pie plots, histograms, and these graphs are generally used to represent the mathematical operation, to represent the mathematical information graphically so that it is understandable to the user and to the stakeholder. Okay, so sometimes it would be really difficult to compare the values with the numbers itself. Okay, so as you can see here, if I am writing all these values like this ranges from 25,000 to 19,000, this range from 16,000 to 16,200. But in case if I have to compare and show that they are on a different peaks, so then I need to have a graph. Okay, and if I draw a graph, that can actually show me the differences between which value is higher and which value is moderate and which values is extremely low, so that we can quickly understand. So we are going to make a plot here. So now what we can do, we can quickly, there is a function known as plot in the data itself. And what it actually does, it make plot of the series or the data frame, and it is going to make a graph, and it will show all the legends available within that data, just in order to have a quick comparison. Okay, so if I run this now here, you can see that we are going to get a graph, and here is the graph available. Okay, so now you can see that we have multiple values available over here. We have the value of price, which is represented in blue color. We have the value of lot size, which is represented in orange color. Then we have the price of bedrooms, bathrooms, stories, driveway, recreational room, full basement, gas, hot water, air conditioning. Okay, now you can see that with respect to the data available, this is the range of the price. Okay, and you can see that it touches a very high magnitude, because the values goes beyond 1,75,000. So this is the biggest value on the data frame. Second we have is the lot size, which falls somewhere here on this range. Okay, you can see that. So it is below the range of 25,000. Okay, and now on the zeroth scale, you can see that it is very difficult to observe all these other observations. Can you see that? It is very difficult now to observe these observations, because these observations are on a very small range. They are in a range less than 10. So it will become very difficult to compare the price with the other values. So I just define it here. So it is very difficult difficult for a data analyst or for a data analyst to compare price with respect to other independent variables. This results in lack of identification of actual independent variables which can help in calculation of dependent variable. And the dependent variable I have already told you is price. Okay, so it becomes very difficult for data analysts to compare the price with respect to other independent variables, and this is because they fall in a very small range. So if the values are on a very small range, we won't be able to compare them. So what do we want? We want that all the values right from the price up till the preferred area, okay, all of them should be represented on a common scale, and this common scale should be in a range which starts from 0 and up to 1. And this can be done with min-max scaling. There is another way of doing it, and that is known as standardization. Okay, and both of these techniques, the technique of min-max scaling and the technique of standardization, is actually known as transformation of the data. Okay, so that's what we will be doing it. I hope this is clear. If this is clear, just confirm me on chat. Okay, if this is clear, please confirm me on chat that you all are clear with this concept. Now, very nice. So I believe it is clear to everyone. That's great. Let's go for it. Let's go for the next part. So now what we are going to do. So in order to solve this problem, okay, so what we will do to solve the problem of different scale of independent variables, we need to use transformation techniques to prepare the data for analysis. Okay, transformation techniques to prepare the data for analysis. This is what we need to do. Now, how we are going to do that? So there are certain techniques of normalization which I would like to quickly show you on Wikipedia first, so that you all are clear that how these techniques are used. So over the Wikipedia, you can actually search for normalization techniques. Normalization. Okay. Let's just go to normalization, and statistics actually would be the better term to search. So I'll just quickly search on Google, in fact, normalization in statistics. Normalization in statistics. Okay. So when you search for normalization in statistics, you're going to get normalization statistics. And I'm just sharing the link of this article with all of you. Okay. As well as I'm adding the link of this article on here also. Okay, so this will be for your future reference. This Trello card will be available even after this training ends up after 15th June. you all can access this board any day, anytime you want, so that if you have to revise, you will be able to get all the relevant resources required. Okay. Now, what next we are going to do? So I'll just explain you what is normalization. So in statistics and applications of statistics, normalization can have range of meanings. There could be different meanings for this. In the simplest cases, normalization of ratings means adjusting values measured on different scales to a notionally common scale. This is the thing which we have to understand. Okay. So what we are going to do, converting the values which are measured on different scales to a common scale. Okay, that's what we have to do it. And how can we do it? So there are certain techniques to do it, and these certain techniques are available over here. So what we can do here, as you can see, these are the formulas which we have to implement. So one of the most common formulas which are generally implemented for normalization, first is calculation of the standard score, and this technique is also known as standardization technique. Okay, we call it as standardization, and this is very common technique which you will be able to understand because it is used in approximately every machine learning analysis or data science analysis. Okay. Now, so you're going to calculate the standard score. Similarly, one of the other technique which is generally used in data science and analysis, and that is known as min-max feature scaling. So this is also very important. So we are going to implement both of these equations. I'm going to tell you how you can mathematically implement both of these equations in Python, followed by you can also use the existing libraries so that it makes your task easy. Okay. So what this means normalizing errors when population parameters are unknown works well for populations that are normally distributed. Okay, so it does not explain the definition much. So for definition, I will also show you one more website which actually defines all these things in a very nice way. So I'm going to share that. But before that, I'm going to quickly explain it by myself. So let's say if you have the independent variables available. So X here is the independent variable. So you have to subtract with the mean value. So here the mu symbol which you are seeing is the mean of all the observations for the independent variable divided by the standard deviation of the values in that independent variable. So we are going to calculate, we have the independent variables available. Out of the independent variables, we are going to calculate the mean of them. And once we have calculated the mean of that, we are going to calculate the standard deviation of that independent variable for all the observations available in the data set. So in our current housing data set, we have 546 observations. So we are going to identify all of them, the mean for each, the standard deviation, and followed by, we are going to calculate the standardized value. Okay. So how we can do it? We are going to test. Similarly, there is another way of standardization, which actually converts the value on a common scale of 0 to 1. Okay. So when you have to convert between 0 to 1, this technique is used. Okay. So how we can do? We can make use of the values of X. We can subtract it with the minimum value of X. Then we can take the maximum value of the independent variable, and then we can take the minimum value again, and with which when we are going to divide it, we are going to get a range of 0 to 1 for that instance. Okay. So now, so let us just quickly, I'm going to quickly show you how we have to implement that, and then I'm going to share the article, share a website with you, which, okay, let me just quickly share the website first with you, where the definitions are available, because they will be very helpful. So let's say I'm going to search for standardization. Okay. So here, if I have searched for standardization, there is, let's say standardization statistics, I will search. Yeah, so this is the website Statistics How To, which is a very nice website and which explains all the algorithms in a very nice way. Statistics How To is one of the nicest resource and the website which you all can quickly refer. So understand the core insights of statistics on this website. Okay, so you can, I'm just sharing the standardization example with all of you, but you all can observe these all the different algorithms which are available. Okay, so now, so I hope this is clear to all the participants that you have got this, and let me just quickly explain you how it is going to perform. So the standardized values can be actually calculated with this formula. Z is equal to x minus mu upon sigma. So x minus mu upon sigma actually defines x is your independent variable. Okay, and what will be an independent variable? Consider, let's say you have an independent variable, let's say bedrooms. Okay, then you have mu. I'm going to call it as mu. Okay, mu will be mean of independent variable. Okay, so mu is actually represented as x mean of the independent variables, and then you have sigma. Okay, and sigma is actually x standard deviation. We call it as standard deviation of independent variables. Okay, so these are the things which we have to calculate. I hope this is clear. Now what next we are going to do? Let us just quickly calculate it so that you'll get to know how we actually calculate all that stuff. So for calculation, okay, here they have also explained x will be the observation, mu will be the mean, sigma will be the standard deviation, which I have already defined, and there they have defined some good equations. Okay, so you can read about it. What is standardization? So let's say in case if you want to read the definition, you can quickly read it from here. The definition clarifies what exactly has to be done. Okay, a standardized value and all these things you can quickly understand about it. Okay, they have explained it very clearly what standardization is and how it has to be used. Now I'm going to quickly take you to how we are going to implement these equations. Okay, so let's just, since we will be using min-max scaling in many cases, so we will be working towards min-max scaling first. Okay, so let's have a look. So I'll go to my code now, and I have to show you the min-max scaling, how it works. Okay, so you can see we have actually calculated the minimum value of price. Okay, so let's say if I show you the minimum value of price, it was 25,000. If I show you the maximum value of price, this value is 1,90,000. Okay, so if you have, for example, if you have to convert this price value on a range from 0 to 1, what you are going to do? You are going to make use of this equation, normalization, and let's call it as min-max scaling. In min-max scaling, what we calculate the x normalized. Okay, we call it as x norm, or let's just call it as like this, x normalized. How will you be able to take it? So you have to get the value of the price. So let's say I'm going to get the value of price, let's say data.price, okay, minus I'm going to get the minimum value of it. Okay, so I'm going to call it with minimum price. I'm going to subtract it with minimum price. Okay, then I'm going to divide that with maximum price, maximum value of the price, minus minimum value of the price. Okay, so if we do it, we are going to get the value of x normalized, and if I quickly run it, you can see that you're going to get the values of the price converted between 0 to 1. So the minimum value will now become 0 and the maximum value will be maximum 1. And if you want to quickly understand it, let's say I say, I'm going to explain you here. Let's say suppose we have the maximum value is 1,90,000. The minimum value is 25,000. Okay. And suppose I have got a value, let's say 16,500, or let's say 165,000. Let's say I have to convert this value into normalization. Okay. Let's say I say I'm going to normalize it. So for normalization, I have to use the formula, okay, x minus x minimum upon x maximum minus x minimum. So what I'm going to do, in order to do that, I'm going to do something like this: 16,500 minus minimum value 25,000. Okay, then I'm going to divide it. I'm going to divide it with the value of x maximum minus x minimum. So how am I going to do it? I'm going to use 1,90,000 minus 25,000. Okay. So once I do it, what I'm going to get? So let's say I'm going to open calculator for you here. Okay. So let's say, so I say I have got 1,90,000 minus, okay, 1,90,000 minus 25,000. So we have got a value 1,165,000. Okay, I've got a value. Let's say here. Let's say I'm going to type it here. I've got this value as 165,000. Okay, 165,000. Okay, just give me a moment. Yeah. Okay, here. So we have got 1,90,000, 1,90,000 minus 25, 123. So we got 1,65,000. Now what we are going to do? We are going to take the above value, 1,65,000 minus 25,000. Okay. So we are going to get the value of 14,000. So if I divide 14,000 divided by 1,65,000, so I'm going to get a value less than 1. So now my value is transformed from 16,400 to 0.84. So 0.84 actually belongs to a range between 0 to 1. Okay. So similarly, now you can understand that when you normalize the values, so you can now convert all the values of different scales on a common scale between 0 to 1 of all the different columns which are available with you. Okay. So this was 1, 4, 1, 2, 3, 4. Okay. So somewhat like this. So this is the way of normalizing the data. But how we can actually normalize the data in our code, that is what I'm going to show you. So we have normalized it for one common value, that is for price at the moment only. Okay. But we want the complete data, which is of a different scale at the moment, which is represented here at the top. You can see that the values here of different range. Okay. Now all these values will now be converted of this data into a common range between 0 to 1. So let's just convert it now here. So I'm going to write it again. And here I'm going to take the complete data for you. So let's say I would like to select the independent variables first, because I want to convert all the independent variables into a common range. Okay. Select the independent variables. So in order to select the independent variables, what am I going to do? First, I generally check my columns. Okay. Well, how many columns do I have in my data set? So you can see that I have these columns. Price is at index number 0. Then I have lot size, bedrooms, bathrooms, stories, driveway, and so on. Okay. So I'm going to keep it into, let's say, independent. Okay. So this time I'm going to save this value into independent columns. Okay. And I'm going to print the independent values, independent. Okay. So you can see that we have got the independent variables, but we have to remove the price out of it. because price is going to be the dependent variable. Okay, so how am I going to delete that? I'm going to call this value delete, and I'm going to delete that from index number 0. So what it does, it makes a new index with a past location deleted. Okay, so in case if there is a 0 index, we are going to delete it, and we are going to shift the values back. So lot size will become index number 0, bedrooms will become index number 1, and so on. So once we delete it, we are going to again save it into independent. Okay, and now if I print independent for you in the next cell, okay, so okay, I'll do it in the next cell for you. So I'm going to delete the independent, and I'm going to show you the values of independent. Okay, so once we do it, now you can see that earlier we had the price on index number 0, but now that has been removed. So all these variables have now become the independent variables which we can use to calculate the price. And now we are going to convert these variables, and we are going to represent them on a common range. Okay, so let's say, so if I make a graph of independent variables here at the moment, okay, if I just clear all the statements, and if I go to the next statement, and if I show you that if I take a graph of this independent variables now, and I make a plot, okay, so now you can see that now we have got only lot size represented here. You can see that we have got the lot size. Okay, this is your lot size, which is now ranging up to 16,000 only. In the previous graph which we have plotted, it was up to 1,75,000 and above. And now since we have the lot size, but still we are unable to compare the values, because all the small values between 0 to 1 or 0 to 10 range, they are just available like a straight line, because we cannot represent those values. And these values are this: bedrooms, bathrooms, etc. So now let us convert all of them into a common range, into 0 to 1. Okay, so let's see how we are going to do it. So in order to do that, let us just quickly go to the next cell, and here I'm going to convert the independent data. So to perform the normalization, I'm going to call the values of independent values, independent, okay, and I'm going to store into X, and let's consider X as a representative of independent variables. Okay, so if I have to calculate X normalized, then I have to implement the equation of the normalization, which I have just told you from Wikipedia. So I'm going to use X minus X dot minimum. I have to calculate the minimum values of X. Then I have to divide that with the X maximum value of the X minus X and minimum values of the X. Okay, and finally we are going to get the normalized values. Okay, so now let us just run it. So if I run X normalized now you can see all the values like lot size, bedrooms, bathrooms, stories, driveway, gas, hot water, garage places, preferred area, they are all now converted on a common range of 0 to 1. Earlier they were of different range, but now they have been converted on a common range. Okay, so if you all are clear till here, just confirm me on chat if it is clear to all the participants till now, that this is how we convert data of different range into a common range, into a common scale. Okay, and now suppose if you want to quickly check the value of lot size now, earlier it was from a range of I think 1,600 to 16,000 something, which we have printed above. You can see that it was from 1650 square meter to 16,200. That was the earlier range. But now from the normalized value, if I use X normalization, and I select the value of lot size, and if I check the minimum value here of lot size, it will be 0 now. Okay, and similarly from the normalized data, if I again check the values of lot size and if I try to access the maximum value, it is going to be the 1. It is going to be 1. Okay, so now you can see, now the range of lot size and all the variables have now been converted on a common scale 0 to 1. So this actually means that if we plot a graph now, they all can be plotted and can be visible on the graph. Okay, I hope this is clear to all the participants, that how you can manually transform the data. Similarly, you can perform the standardization also, that is x minus x mean upon x standard deviation. Okay, so that is known as x standardization. But in the standardization, the values fell on a common range, but depending on the standard deviation, it can be beyond 0 to 1 also. Okay, in standard deviation. So it is generally preferred to use min-max scaler. You can use it whenever you are trying to implement analysis on a data where you have different scales available. You can quickly convert them into common scale. So one thing which I want to tell you, yesterday or on the session number 2, when I have told you about telecom data, in that telecom data, the values which were available to you, they were all normalized like this. Okay. So you won't be able to understand about the data what it is when you will be processing any data coming from an organization, because they will always be normalized. Okay, and normalization means they will always be anonymized. You will not get to understand the data whatever is available. So you just need to apply the algorithms on it, and you need to identify which columns are matching to what other columns, and then you have to give that analysis back to the organization, and the organization will decode that algorithm and put it with their original values. Okay, so most of the analysis which you guys will be doing, let's say in case if you are participating in a datathon, okay, and suppose some bank is providing their data for you to analyze it. So they are not going to give you the data of real consumers. The data will always be of a real customer, but it will always be normalized and anonymized. So you won't be able to understand the transaction information of any person with respect to other person. They will always be represented with person IDs and whatever the transaction value was, and from one destination to other destination, they will also be in numbers. Okay, so it is a very important thing for every machine learning or data scientist to understand, that whenever we are going to receive a data from an organization, it is always going to be numerical mostly. Okay, in case if they want to preserve the privacy of the data whatever they are sharing, so you always will be implementing your analysis on the data which will be available to you in numbers format in most of the cases, until and unless you are collecting your data on your own. Okay, so now, so let's see, I'm going to proceed further. So you have normalized it, and let's just quickly make a plot of the normalized data. Plot the normalized data to see all observations in the data set. Okay, so now let's say I'm going to use X normalization and I'm going to make a plot on it. Now once I make a plot, now you can see that all the ranges are from 0 and 1. So it becomes very ugly. Again, you are unable to understand that in a much better way, because the values are now between 0 and 1, and they might confuse the information with respect to all the 500 observations. But at least what you can do now is you can have some scatter plots, you can cluster them, and there are various other different graphs which we can plot, where we can actually analyze what kind of information we can fetch out of this. Okay, so whenever we have to actually calculate the comparison or the relation, we generally try to plot the correlation analysis of that. Okay, so for that you can actually calculate the correlations, and you can observe the correlation even after the normalization will be actually same with respect to the previous correlation analysis it was. Okay, so let's say before after normalization, let's say lot size is 0.15 correlated to bedrooms. Okay, Similarly, if we can go to the previous correlations which we have checked, okay, so you can see that lot size was 0.151851 in comparison to the bedrooms. So even after normalization of the data, even when you convert the data from a different scale to a common scale of 0 to 1, its properties does not get changed. Okay, so that means their relevance, their influence is going to be same. Now, I'm going to show you how we can make a very nice, beautiful correlation plot so as to quickly observe them with the graphs. And in order to understand which of these graphs are actually, which of these graphs are actually useful, and which of these observations are actually useful in prediction of the price, or how they are dependent, or how they are relative to each other. Okay, so that we can do with correlation analysis on Dataiku, and we can also use a seaborne graph which can actually be plotted. So before I plot that, I would just like to give you a quick understanding of how it can be done on Dataiku first, and then we are going to plot a graph there, and similarly that graph we are going to plot in our script. So now all the participants switch to Dataiku, where you have got the housing data set prepared, which was converted into numbers. One thing which I want to do is, let's select it. And after selection, you have to click on the lab. Okay, so you select the housing prepared and click on lab. Once you click on lab, you're going to get some features here. So the part data.correlation which we are doing in Python, we can also do that in Dataiku. Under the predefined section, there are some dimensionality reduction techniques available. Identification of correlation is also known as a dimensionality reduction technique, because in the analysis we always consider those columns which are actually either positively or negatively influencing the response variable. So with correlations, you can identify what all variables are quite influencing the response variable and the price. Okay, so we will select only those columns for analysis, because in real cases it might be possible that there are thousands of columns. So it won't be a good idea to process all the 1,000 columns, even if they are not influencing the response variable. So first we check the correlation. Once we get the highly positive response, highly positive influencing variables, we select those variables, and then we analyze only those variables. Okay, so that the processing gets fast and we can perform the data science and machine learning analysis well. Now, once you guys are done with that, let me just click on it. You have to go to the correlations. Now there are multiple options available. So first thing which we have to do is correlation analysis. So it was very simple, as you all can see. It was very simple in Python. Just we have to execute xnormalization.core and we get the correlation values. So this actually says that lot size is 15% positively influencing bedrooms, and the maximum it is influencing is air conditioning somehow, garage places somehow. So it is quite natural. So in case if the lot size is big, definitely you are going to get more area, and if you have a more area, then you can make more number of garage places. It is possible. Okay, similarly, if you have a bigger lot size, so you can create more number of bathrooms. It is possible. Hence it is saying it is 90%, 19% possible, but somehow it could be possible in case if we have a big area. Let's say I have 5,000 square yards of plot available, and within that I have made 3 BHK, 3 bedrooms and 1 bathroom only, and I have made a very big bathroom. So it is also possible. But there is a positive influence that if you have a bigger area, if you have big lot size, then it is possible that you can make more number of bathrooms in it. Okay. So this is just a real observation of the data, what is exactly happening. And similarly, there is 35% cases in the data set where if the lot size was more, the number of garage places were more. Okay, like that. So let's say if you are staying in a very small lot size based house, then it may be possible you don't have a garage, you don't have a garage place to park your car, and kind of that. So you can relate all these things with the reality. Now, once you have got this, once you have calculated the garage places and everything, once you have calculated the correlation, this you can actually do with the Dataiku also. And how we can do it simply, let's have a look. So I have selected the correlation analysis. and the name is automatically selected that we are going to perform correlation analysis on housing data set prepared, and finally click on create. So once we click on create, what is going to happen? Automatically a Python code will be written. You don't need to write the Python code. Automatically the UI is going to create a Python code for you, and it is going to perform the correlation analysis for you. Okay. So what am I going to do? Just simply run the cell. So we are going to run all. Okay. So once we run all, you can see that the code which we are actually trying to write in Jupyter Notebook, all these things will be executed here. So somehow they have taken the data set and they are showing that we have 546 rows and 12 columns. And I can show you how you can quickly show this particular step. Okay. Followed by, this is the correlation matrix which they are going to plot. Okay. So again, they have used a data frame and they have used the correlation analysis. And within that, they are checking in case if there is any null value, fill it with 0. This I have already told you that how we perform pre-processing on our data. In case if there is any missing value, we are going to fill it with 0. Then once it is done, it has actually made a plot and it has made a heat map for you. Okay. So you can see that we have got a heat map here. Okay. So we have got the price has been removed out of it. Only the response, only the independent variables are taken. And let's say the independent variables are lot size, bedrooms, bathrooms, preferred area. And it is actually showing you a color matrix. In this color matrix, what exactly is happening? Let's say this is a color range of lot size. Okay, let me just change the color. Let's say this is the color range of lot size. So we have to match this color range with the graph here. So it matches somewhere here. Okay, you can see that. So once it matches somewhere here, that means lot size is approximately 40 to 50% correlated to the individual observational variable price. At the very bottom, you can see that we have the price available over here. Okay, so the same graph we are going to actually make in our Python script, but we are going to make one change in it. We are also going to display the values here so that we don't need to match it again and again with the color bar here. Okay, so that's what we are going to quickly do. So how we can do that? We have to get a piece of code which we have to use. So here is a very quick piece of code which we are going to use. I'm sharing this with all of you on the Trello card also. You all have to copy this script code with you. Okay. And these are the two steps. These are the comments. So you can ignore the comments. These are the commands which you all have to use to generate the heat map. And just I'm again sharing the link to this board so that you all can quickly access this Trello board. Okay, just open the link and get access to the Trello card. Okay, once you guys have got this Trello card, once you guys have got the code, just go to your house price project, and after the correlations you have plotted, just paste both the lines of code. Okay, so I'm going to copy both the lines of code here, and I'm going to explain you what they actually do. So this is the setup process. This is the draw process. Okay, now what we are doing, we are actually setting the size. Okay, we are actually setting the size of the correlation. Now what is this correlation? This correlation variable will be a correlation from here. We are going to X normalize and we are going to make a plot. Okay, or else what we can do, there is one more option. You can actually use the data directly to plot the correlation. Let's say we are going to use the data variable because it is similar. Even if you take the data variable or the X normalize, the only difference will be in the X normalize you won't get the price. But here we want to actually check back how many of these independent variables are actually relating with the price also. Okay, so what we are going to do, we are going to use the data variable and we are going to calculate the correlation analysis. So this variable will be stored into core, and now this core and all the columns in the correlation will be identified and the maximum size will be selected, and we're going to get a subplot. And as soon as you progress further, we can also discuss about what subplots are. So you can make a graph, and within one graph, you can make multiple subplots. You can have multiple graphs in one single graph. So for that, we generally make use of the concept of subplots. And the major objective of using the subplot is we can define the figure size. Okay, we can define the size of the image or the plot which we want to make. That's why we use this option. And finally, you are going to get the figure in return and the axis in return. So axis will be the axis 0, axis 1, so that you can arrange multiple graphs, column wise or the row wise. Both ways it can be done. And just to make the plot, you have to make the heat map. Okay. There is one more feature which we have to enable here, and that is the feature of annotation. Okay. Annotate equal to true. We are going to annotate it as well, so that once we annotate, we are going to get the appropriate value written over the color plot. So here we have used the heat map, and we need to import the seaborne as well. This is the library object SNS which we have to use. So to import the seaborne, we'll quickly go to the top and we'll import the seaborne here. So it is very simple process. Import seaborne as SNS. Okay. So this will be the final code. So I'm just updating the previous code here. This should be the final code. Okay. Import seaborne as SNS, as well as the correlation.data.core and SNS.heatmap. Now, once you have got this, so we have got the correlation of the data that we are going to get. We have annotated so that we are going to get the values of the correlation analysis printed on that color graph. Then we are going to have a mask. We are going to square it so that all the pieces will be appearing in a square format, so that it will be easy for all of us to observe. Okay. Then it is going to be your color bar. The color bar is going to be shrink with 50%. And now let's see. Let's run this. Now here, okay, mask is not defined. If you want, you can remove the mask, or else we can take the mask values here from here as well. What is the mask value they have? So for the mask, what they are doing is they are just removing the upper mask. So once you make a plot, it becomes dual graph is made. So I'll just remove the mask here for a moment, and I'll show you what is the difference. And then what you can do is you can use the mask and make a half plot. So generally, once we make a plot, you can see that you're going to get a plot somewhat like this if you remove the mask. So in the mask, you're going to get two graphs, okay? And each half represents all the values, in fact. So in case if you observe this particular part from here, okay? So this graph, so this, you can consider this as the first block. Let's say we can call it as the first block, and this is the second block. So both the blocks are similar. Okay, both the blocks are similar. So with mask, what you can do is you can remove the other side of the block. Okay, and how is it actually represented? I'm going to quickly show you before we proceed further. So for now, we have removed the mask, hence we are getting the both the graphs. And now you can quickly check back the correlation analysis. Which plot is more relevant for price data? And now with the color graph, it is very easy to observe the light colors. So dark colors will be negative influencers. Okay. So if you have any dark color, it is going to be negative influencers. If you have light colors, they are going to be positive influencers. So with the color matrix, we can quickly observe that yes, this one is a high influencer. This one is also a high influencer. With the color, we can easily identify. Bedrooms is also a high influencer. So we can see, okay, the price is dependent on, price of a house is generally highly dependent on the bathrooms, the central air conditioning, as well as on the lot size. Okay, you can see that, as well as on the lot size also, the graph, it is positively influencing. Okay, I hope this is clear. And this is the comparison of that particular attribute with its own self. So it says 100%. So in case if price is going to increase, definitely on the axis price is going to increase. That is why this 1 is represented as the cross. Okay. So for each specific value, bedrooms in comparison to bedrooms, let's say lot size, when it is compared with lot size here, so it's going to give you the value as 1. Okay. It means this. And lot size when compared to bedrooms is 0.15. So with these kind of observation, what generally we can do, we can actually identify that not just price, we can even also identify what are the other factors in the data which might be dependent on each other. Okay. So as you can see, we can see that this value of 0.37 of recreational room is actually influencing full basement also. So if we have a drawing room, it could be possible we can have a full basement also, and basement and drawing room or a recreational room have positive influence. Okay. As well as there are other positive influences like we have a 0.35 here on the color, which you can see lot size is also dependent to the garage places. So in case if we have more number of lot size, if we have a bigger lot size, it could be possible we have a bigger space. As well as there are some negative influencers also. Okay. So number of stories, it does not have any relation with the lot size. Okay. Suppose you have a 500 square yard home. It is your choice. You can build 1 floor, you can build 2 floor, you can build 3 floor, you can build 4 floor. Okay. It doesn't matter, because with the increase of size of the house does not matter with the increase of the number of stories. It could be possible that a big bungalow, which is of let's say 1000 square yard, it is already very big and they can have only 2 floors. Let's say it could be a duplex, a ground floor and a first floor. And suppose there is a very small place, let's say there is a 90 meters house. Okay. So 90 meters house will definitely have 4 floors because they don't have more space on the ground. So what they will do, they will try to build up more space above in floor wise or the story wise. Hence it says it is negatively influencing. If you have the less space on the ground, then eventually people are going to build more number of stories in that particular house. So that means it is a negative influence. So somehow like this, all these real insights you can actually observe from the data with a quick correlation matrix. Okay. And you can do it both ways. You can do it programmatically as well as you can do it with Dataiku. All these things are very, very simple. And to tell you, data analyst is one of the highest paying jobs in today's industry. Everybody is seeking a data scientist or a person who can analyze the data, who can quickly read the data from their databases and observe these things like they plot the correlation analysis, check what all factors in the databases are actually related to the other variables. And using this, we can identify different problems and we can identify solutions to the problems which we are currently facing. So what can happen, suppose consider a real scenario where we are experiencing some business losses. So what we can do is we can collect the complete data of the previous year where we made the losses. We can quickly make a correlation plot, and let's say we can identify the relation of different facts with respect to the loss. And if we find out certain factors which are highly positively influencing the loss, then we can identify that, okay, these were the factors due to which we made the loss. So in the next financial year, we are going to make sure that we are not going to perform those actions which made us loss in the previous year. So it's always very difficult to quickly observe in a day-to-day activity about the businesses, because businesses are very long-term activities. My today's action on my business is going to give me an effect after 5 months from now, maybe. Okay. So it's like pre-plantation. So once you have to have a successful business understanding about with your actions in future, whether this is going to be profitable for your business or not, you should be able to perform all this analysis so that you will actually get the real insights. Okay. And as you all know, big companies, those who actually implement those techniques, those who follow the results of those analysis, they always make profits. They are always in plus. Okay. And even if they are in loss, they already know what could be the reason. So they work out on the reasons, they come up with the new products, and again they come back into business. So this is all what you all can do if you all can analyze your data appropriately. So this was about uh, transforming your data. Okay, and similarly, it's not just with your data price. Whatever influencing variables we have actually extracted with the normalization also, we can quickly convert that into X norm, and we can plot a normalization value chart also. Okay, so suppose now I have actually calculated the normalization value chart, but it is of not much use because our actual objective is to identify the relation of all our independent variables with the price variable. Okay, so I believe everybody is clear with this concept of how data transformation has to be done and how you can actually plot the correlations. Now, once you guys are done with that, let's just quickly implement one more part. Let's say implement standardization. That is also a very easy process. Or else, before reaching out to standardization, I would like to show you there are existing libraries which you can use. Okay, normalization using min-max scalar library. Okay, so we have min-max scalar available from sklearn. Okay, so what we are going to do, we are going to import sklearn dot. Within the sklearn, we have, I think, stats models API or dot metrics from sklearn. I'll just quickly check. I think it should be in the pre-processing itself from sklearn dot pre-processing import min-max scalar. Yeah. Okay. So you can import min-max scalar. Similarly, from sklearn dot pre-processing, you can import standard scalar. So standard scalar is also a standardization technique. Okay, this is standardization formula, which also I've shown you, and this is the normalization formula. Okay, so how we can do that? So you can quickly import min-max scalar. Okay, let's just remove this. Let's simply import it like this. So once you have imported, we are going to call min-max scalar. This is going to be the min-max scalar. What it does, it transforms features by scaling each feature to a given range. So the way we implemented the formula above, you can actually implement it with the function itself. And what it implements, it actually implements the standardization value somewhat like this: x minus x minimum with axis equal to 0 upon x maximum minus x minimum. This is the standardization. And x standard into max minus min plus minimum, that is the scaled version. Okay, so these are the values of min max scaling which can actually be done. So let's say we are going to have the min max scalar, and let's call it as mm. Okay, so we are going to use mm, and you can use mm dot fit. There is a method known as fit transform. Okay, so with the fit transform method, what you can do, you can actually provide the x value, which is going to be your independent variables data, and you can quickly transform it. Okay, so let's say if I want to transform my data, I'm directly going to call data, and if I run it, it is going to quickly convert that into an array. So similarly, above, as I can show you that once we have transformed the data with our formula directly, we could have done it like this. We have arranged it in a data frame appropriately. All the values have been converted. Similarly, using min-max scalar also, you can quickly convert the data into a normalized value for all the different columns which are available. Okay, so this is also a way of using min-max scaling using the existing libraries. Similarly, if you have to perform standardization, standardization is also similar, and I'm going to quickly show you the formula for that. Standardization is x minus mu divided by sigma. Okay, so this is the formula, x minus mu divided by sigma, and this can also be represented as x minus x mean divided by x standard deviation. Okay, this is also a formula. So what we can do is, let's say if we have the data, let's say if we have the x factor, so I'm going to call it as x standardized as x minus x dot mean value. You can actually check the mean also. Okay, so x is the previous value of the independent which we have taken above, divided by, you can actually take x dot standardization, std. This is a function to calculate the standard deviation. So once you do that, you are going to get x standardized value. Okay, so now you can see that we have again converted the value into standardized format. So using this formula, you can use lot size, bedrooms, bathrooms, and it will naturally be converted into the standardized values. So when it becomes standardized, your data becomes anonymized and you can perform analysis easily. And similarly, if you want to perform that with a standard scalar, you can also use the standard scalar method. You can call it as SS. And using the standard scalar, you can call this function fit and transform the values, transform, and you can call them on your, let's say, X, and you can also save that into XSTD, let's say. Let me just execute in the other cell so that you will be able to have the differences. Okay, so here if I run XSTD, so you will be able to see we are going to get an array with the standard scale. Okay, so similarly, we have got the values here. Let's say the first value for the lot size is 322,732. Similarly, you are going to get the standardized values also, okay, for the specific versions. So now, this is how we can actually perform the standardization over the data as well as the normalization of the data. Now, what if we have to perform this standardization under our our Dataiku project? So we'll quickly go to the flow, and in this flow, we will start analyzing the data. So how we are going to do that? Once you come here in the Explore, you have to select the data set. You have to click on Lab, and now we have to create a model. Okay. Now we have to prepare the data and build the models. This is the process which we are going to do. Okay. So how we actually configure the normalization part and the transformation part, we are going to do that. So now we are going to perform a visual analysis on the data. So first we are going to perform transformation, and how that transformation is done, I'm going to show you in the selection process. And once we do mining on Dataiku, we are going to observe how the scaling has been done. Okay, or how the transformation has been done. So this is also called as a scaling process, where you scale from different range to a common range. Now let's quickly create it. Once you click on create, you're going to get price, lot size, bedrooms, bathrooms, stories, driveway, and all that values are available over here. Okay, but we have to prepare the models. Okay, so we go to the models at the top, and we are going to create the first model. So in order to create the first model, it will ask us, what do you want? Do you want to perform the prediction, or do you want to perform clustering so as to identify the patterns? So how do we identify? So whenever our outcome is continuous, okay, whenever the outcome or the dependent variable is a number, let's say it's continuous, okay, or it's a quantity. Whenever you have to calculate a quantity like price, then we perform prediction. But whenever you have the data where the outcome is a category, okay, we call it as a category. Okay, let's say if you have to predict yes or no, if you have to predict most likely, somewhat likely, least likely, somewhat like this. Okay, if you want to predict something like would I be liking the new upcoming movie or not, so now the choice becomes a category, either yes or no. So in that case we perform clustering. So currently we have the data is price. It's a quantitative in nature. So we are going to perform prediction. Okay. So once we select the prediction, you have to select the target variable. This is the selection process. So I'm going to select the target variable as price. Okay. And now I will go to the export mode where I'm going to configure each and every step. And in this step, we are going to configure the transformation part, that how we are going to select the min-max scaling. So we'll quickly go to the export mode. We'll select the algorithms which we want to choose for it. We are going to quickly click on create the model. Now, so by default, it has landed you under the algorithm section, but we have to start from here, from the very first. So under the basic section, just come to the target, and you can see that the target is quantitative in nature. Since the target is price, automatically regression is selected. And it could be a two-class classification, multi-class classification, or regression. All these three things we can do. Okay. Then training and testing, cross-validation, I'm going to tell you about it as soon as we progress further. The metrics displays R2 score, which means what should be the outcome and how will we be comparing the different models, which model is better. So R2 score generally represents the accuracy of the equation in prediction of the outcome. Okay, so this is also known as the accuracy. So this accuracy defines which algorithm can successfully predict the outcomes, okay, from the data. So we will be working out it. I will be explaining you this in more details as soon as we come to the next part, that is tomorrow, when we will be working on mining and evaluations. Okay, but now, as of now, I would like to show you the features for the feature for min-max scaling and the standard scaling. Okay, so where is it available? So under the features, you can see here, you can come to features. You can see you have all these features which will be selected. After correlation analysis, something if you see stories is not positively influencing the price, so we can remove the information of stories. We cannot count, we don't want to count it on the analysis process. We can do that. Okay, but I'm going to explain you how we select the specific variables and how we ignore that. I'm going to tell you that. Now here comes the feature generation. So the feature generation is also available over here. Okay, one more thing which we have to identify over here. Okay, so these are the distributions, the minimum values, the maximum value. So you can see that the minimum value is 25,000, maximum value is 1,90,000, mean value is this, standard deviation is this, median is this. So we have also done all these identifications in Python also, okay, which this Dataiku is automatically doing it. So generally, once you learn data science and machine learning, once you know how the Python code is executing, then you don't need to code it again and again in Python. You can make use of an enterprise tool like Dataiku to perform your analysis, and it will make your life easy and it will save a lot of time. And when you go into a company, you will be working on the tools like this. Instead of working on the program script directly, you will be working 90% on the enterprise tools like Dataiku, Pentaho, and there are various other, so as to reduce the development time of the product. Okay. Now, once we are done with this, then we have feature reduction. Okay. So you can see that we will be using correlation analysis for feature reduction. Then we have, yeah, here we have got this. Okay, one thing which is missing over here is the min, max, and scaling part. I think we should be able to see it here in the training and testing set, maybe. Policy is split the data set. Okay, split the profile, sampling methods enabled, and in the metrics we have this. In the features handling, we have this. Okay, yeah. Here in the features handling we have. So suppose we are going to select all these features: price, lot size, bedrooms. We have selected all the features, and now on the right hand side you can see that all the data of your pre-processing and everything is available. So in case if you have a missing value, what do you want to do? I want to impute with mean or else if you want to impute with medium, you can actually select, which I have already told you in the previous session. In case if the value is empty, you can replace that empty values using fill NA, using either the mean or the median. Similarly, how will you be performing rescaling? Rescaling is the tree transformation method. So by default, either if you want no rescaling, it means it's not going to implement standardization nor min-max scaling. If you use average STD rescaling, it is going to use standard scaling, and it is going to use the formula x minus mean upon sigma. And if you use min-max rescaling, then what it is going to do, all these variables will be min-max rescaled. So that means irrespective of their range from minimum to maximum, they will be actually converted on a common range of 0 to 1. Okay. So this is how it's very simple in Dataiku to quickly make use of min-max scaling. But in Python, you can quickly implement that with Python, with the equation or with the mathematical equation which is available. So work of a data scientist is very easy. Just you need to understand each of these things step by step. Once you understand the steps, you can actually do it with programs. The programming is also very easy for data science, and you don't need to be a very hardcore programmer in order to learn data science and make data science products. It's very easy. Anybody can get started with that. A couple of days of learning Python programming, like 2 to 5 days learning Python programming on Hack with a 1-to-1, which is a free course available on Python programming on our website, can help you learn Python quickly. Then we also have a complete free course of implementation of the projects or various projects on machine learning, which also you can observe on Hack with a 1-to-1. We have integrated applications and all that there, how you can integrate the applications with machine learning models, how you can deploy on server. All these things you can learn there, as well as you're learning here in our session also about how you can work out on telecom data set and how you can quickly make a product of data science and integrate with the web application that we will be doing in. So for today, you are clear with the concept of data transformation, where you have done rescaling, and rescaling process is also known as transformation process. So in this, generally, there will be a lot of terms which will be similar and but will be treated or taken as with different names. So you, once you will be using multiple tools and softwares, you will become more comfortable with all these terms and how these are used in the analysis. Okay. So this is how we will be doing it. And tomorrow, once we will run this model, we are going to identify different algorithms, that how different algorithms can be tested on a common data set. So we will be having these n number of algorithms, which we will be actually testing on our data sets in order to identify which algorithm is the best algorithm in prediction of the current outcome. And once we have got the algorithm, we can integrate that algorithm with our what do we say, with our website or with the mobile applications. Okay, so that's all for today's session. So we have successfully implemented the following stages in graphical mode as well as the programming mode. You have done selection, you have done pre-processing, and today you have completed transformation also. Tomorrow we will be covering the part of data mining and interpretations and evaluations. If there is any questions, feel free to post your questions, as well as if you have liked the session, hit the like on our video, as well as you can subscribe the channel. Plus, I would really recommend to reach out to Hack with a 1-to-1. In that Hack with a 1-to-1, we have actually provided these programs free of cost with a lot of detailed description about each and every stuff. So I really recommend you all the people, those who are not aware about Python programming, you should definitely go to Python programming. It is very, very easy, and it will make your life a lot easier, and you will be earning a lot of money with your career if you are working towards the programming side. So here we have implemented the sessions on Python programming. They are very simple programming. Syntaxes and all the basic requirements are written over here. And within like 3, 4, 5, 6 sessions maximum, you will be comfortable with coding for data science. Okay. Secondly, there is a second course, data science and machine learning, which has this complete house price prediction project implemented with a complete website deployed on AWS. Okay. So in the 6 sessions, introduction to machine learning, data science studio, pre-processing transformation, comparative analysis, model tuning, and finally deploying the application on the server, configuration of the complete server, integration of the machine learning model with the web application, and finally designing the responsive website and hosting it live. So a complete project on machine learning is also available on our website. That is also free of cost. Okay. And you will be awarded certificates for completion of this course also after the evaluation. Similarly, you are going to get the certification for your current RGPV training also. Okay. So all the participants, those who have who have understood this, kindly complete all of the stuff, and uh, that will be all for today's session. Next, we'll catch up tomorrow and we'll continue here. Thank you so much. Okay, sir. Anybody would like to speak anything to the participants, or else we can conclude the session.
Hello.
Please
Hello.
speak, and it would be good to turn your cam on. That will be like.
Okay. Actually, sir, right now I'm not in my house. I'm right now out of station, so I cannot start my camera. Uh, the session was very wonderful. I was hearing it, but I cannot properly do. But it's very comfortable with the students also. They are it's helpful for them also. So thank you so much for the session, sir.
Okay, thank you so much.
Okay, thank you.